And now for yet another color model. This one's very important for print graphic artists to understand, because the print industry relies so heavily on it. That's why the print icon appears next to the title of this slide. CMYK stands for cyan, magenta, yellow, and key. Key is technically a wild card. It's rarely anything other than black, but they didn't want to use B because that might be confused with blue. CMYK being a subtractive process means absorbing light wavelengths rather than emitting them. The wavelengths that are left over after the subtraction is the color your eye sees. We're talking here about ink on a page rather than dots on a screen. Each printing ink subtracts colors and only allows certain colors to reflect back off the page, so it's completely different than the additive process of RGB. As explained in an earlier slide, RGB is like having little groups called pixels of 3 red, green, and blue flashlights. Each of these pixels is a mix of those RGB flashlights shining in different intensities, and that additive mix is the color that you perceive. This subtractive mix of CMYK is the exact opposite of that. CMY colors are the inverse of RGB colors. This is clear from looking at this diagram. You can see the red, green, and blue that are mixes of CMY, and then in the middle you see black. Black, the K component, is added to CMY because the CMY ink combination alone prints dark brown, not black. Theoretically, it should be pure black when you mix cyan, magenta, and yellow, but because of impurities in printing inks, you'll never get black that way. Occasionally, some ink color other than black is used as the key element. The key element could be brown instead of black to create, for instance, brown sepia tone images. The fourth element, key, makes this color model much more complicated than RGB, because now you have to determine when and how much black ink to add to the other three to make up for the fact that the other three alone cannot create pure black color. As explained earlier, this is the primary color model used in printing of magazines, brochures, packaging, and posters. I'll explain why this is later. This color specification method involves numbers that describe the percentage coverage of ink for each C, M, Y, and K value. You might ask, coverage of what? The whole page? Well, it's coverage of tiny distinct areas called halftone cells, which are similar to the pixels in RGB. I'll cover halftone cells in a later slide. You can see in this example that we've created with this CMYK model the same orange color that we've created in the RGB and HSB slides. We've created exactly the same color in all three models, but it's important to note that not all RGB colors have CMYK equivalents. This is covered in the next slide. So here's another thinking on your feet challenge question. Pause the video and think about the answer to this question. When you have an idea of what the answer is, check it by unpausing the video. Congratulate yourself if you figured it out. The answer is that since we're talking about ink on paper here, and we assume the paper is white, then no ink of any kind would be white. The CMYK color model has a smaller gamut than RGB. What does that mean? A gamut is a color space. LAB is a scientific color model that includes all the colors your eye can see. That's represented by the entire white canvas. The dotted line shows all the colors that can be represented in the RGB color model. Finally, you can see the CMYK color model, which is a substantially smaller gamut of color. The shaded areas shown are out of the CMYK gamut. That means that if you're using CMYK, you're basically ruling out using a lot of RGB colors. That's a lot of colors, as you can see here. The moral of this story is that if you're going to print something, you have to use CMYK, but if you're not going to print it, don't use CMYK because the gamut is much smaller. You can convert an RGB color to CMYK, but if that RGB color is out of the CMYK gamut, it will round it off to the nearest CMYK equivalent, which may be a pretty different color. If you're doing print production on a computer, you should test that RGB to CMYK conversion to see if that rounding off process results in an acceptable color. Note that there are some vibrant neon CMYK colors that you cannot reproduce in RGB, shown here. These are areas where the CMYK gamut is slightly bigger than the RGB gamut, but there's only a few of these small areas where you can have a CMYK color that's not reproducible in RGB, so it's pretty insignificant. The reverse of that is a much bigger problem, that is, having an RGB color that is not reproducible in CMYK. As you saw in the last slide, there are some RGB colors that cannot be reproduced in CMYK. That includes some bright neon colors. Also, as you saw in the last slide, CMYK has a wider range of color only in a few small areas. For instance, pure cyan and yellow are not reproducible in RGB. The moral of this story is to never use CMYK as a color model for any of the items listed here. In other words, don't use it if you're creating anything except a commercial print product. I qualify print product with the word commercial here because there are lots of times you create things that are intended to be printed on an office printer, like Microsoft Word documents. For documents like that, CMYK is optional, but only because you may not care so much if the color is not exactly the same as what you see on your display. But if you were sending a job to a print shop to be printed on a printing press, always use CMYK. This is because, as you saw in the last slide, the CMYK gamut is smaller than RGB, so you may run into problems if you use RGB or HSB to specify colors that the printing inks cannot reproduce. Here is a skills application challenge. Open the graphics program you most commonly use and find where in that program you set CMYK colors. Play around with it for a while until you're comfortable using it, then go to the next video.